So here we have a SAMS question from the Unit 2 WJC exam. As you can see, it is extremely similar to the examples I've already looked at. In this case, we have two particles of mass 2 and 5 kilograms respectively, connected by our light and extensible string over a smooth pulley. So B is at rest, it is then released. So calculate the magnitude of acceleration of A and the tension in the string. Well, the first thing you've got to remember to do is to label the diagram. Now, obviously, we have our tensions. Again, constant throughout because the string is light and extensible. And our accelerations. Now, obviously, A has mass 2 kilograms, so we have a 2g weight acting downwards here and a 5g acting here. And obviously, common sense would suggest that the acceleration would be acting upwards on the 2 kilogram side and obviously downwards on the 5 kilogram side. So effectively, that is our diagram set up. Now all we need to do is apply F equals ma. So if I look at the side to the left, so if I look at inspect A and apply F equals ma in the direction of motion, which is upwards, I'm going to get an equation that is T minus 2g is equal to 2a. If I now look at B on the right hand side and I apply F equals ma downwards, i.e. in the direction of motion again, then we have 5g minus t is equal to 5a. Again, we can do our usual rearrangements on the left and we get t is equal to 2g plus 2a, and that can be directly substituted straight into the second equation. So we end up with 5g minus 2g plus 2a is equal to 5a. So 5g minus 2g minus 2a is equal to 5a. And then we gather our g's and our a's, so we get 3g is equal to 7a. So 3g over 7 is equal to a. So that would be our acceleration is 3g over 7 ms to the minus 2. Again, you could put that into your calculator and get an answer to 1 or 2 decimal places as required. Now, obviously, we can substitute that straight into our tension equation. So our tension would therefore be 2g plus 2 lots of acceleration, so that would be 6g over 7. 6g over 7. So that would go to 14g over 7 plus 6g over 7, which is equal to 20g over 7 newtons. And again, you could put that into your calculator. What I always try and do, though, is do everything as much as possible by mental maths and written calculation, and then check through, and then I'll put my answers in a decimal form when required. The part B question then says, what assumption does the word light in the description of the string enable you to make to your solution? Well, as you remember from my first video, light means tension would be the same throughout the string on